Assalamualaikum warahmatullahi wabarakatuh. My name is Iqbal bin Safaat. I am from JTKE program, Jabatan Kejuruteraan Teknologi Engineering, and my course is BNE. And for my supervisor is Puan Majulana binti Zulkifli, and my co-supervisor is Dr. Norain binti Sahari. Today I would like to present about my research. My research title is Thermal Analysis of Transformer on Distribution. And the abstract, we can see in engineering, transformers are used in a wide variety of applications, some of which include the production, transmission, and distribution of energy. It does this by using the principle of electromagnetic induction, which converts an alternating current AC with a specific voltage into a direct current DC with a different magnitude. In this research, we'll use 3D modeling to forecast the thermal performance of transformers, to conduct the simulation and get the thermal performance of transformer using finite element analysis method. The simulation result will be compared to the actual result of the experiment which will be conducted. The experiment thermal camera specification will be compared with those of the other thermal cameras to determine which of the thermal cameras is the most effective one to utilize when assessing thermal performance. For the introduction, problem segment, thermal monitoring of transformer is important to ensure the transformer is in good condition. If the transformer of the transformer is too high, it is indicative of fault that can further damage the component inside the transformer is left unchecked. The increase of transformer also has a potential to shorten the transformer lifespan. This study will analyze the transformer rise in winding and component inside transformer above ambient transformer temperature by using thermal 3D modeling. The measured data from industrial transformer was obtained by using thermal camera. The objective of this research is to perform 3D modeling simulation core of transformers using SolidWorks to analyze the performance and output obtained from the simulation of thermal transformers core. For the third point, to compare the simulation output with the experimental data obtained by thermal camera. And the last point, for objective, to identify the suitable and efficient thermal camera to detect thermal performance during thermal condition. And for scope of the study, for the first point, to determine parameters for previous research and go site visit to company that have transformer. Second, in order to determine the core transformers thermal performance, parameter will be used to simulate 3D modeling in SolidWorks. And the last one is thermal performance simulation are created using 3D modeling in order to get the transformer temperature of the core constituent and compare it to the real temperature measured during the site visit. And for the past research, first one is to analyze thermal performance by using a sophisticated 3D heat transfer and fluid flow finite element method (FEM) model. For the second point, it offers a comprehensive thermal modeling tool that is able to provide accurate prediction above the distributions of the transformer under a variety of loading conditions. And the last point is should concentrate more on identifying the adoption of appropriate turbulent model for the all and for the recommended the author state it should concentrate more on identifying the adoption of appropriate turbulent model for the on circulation to acquire correct heat dissipation modeling in transformer cost and winding according to the recommendation made in the study. For the reference of the study above is C line MA analyze for of the titled Power Transformer Thermal Analysis by using Advanced Coupled 3D Heat Transfer and Fluid Flow FEM model. And for the methodology, on the flowchart, we can see we begin with the literature review and do a 3D modeling and continue to the simulation thermal analysis and comparison to the actual reading on the site visit. And for the site visit, we will compare the thermal camera that used on the site visit to the other thermal camera specification. They are better than the site visit thermal camera. And from that, we can know the 3D modeling at the right side, and the thermal analysis we use is FEA, the finite element analysis method. And to compare the actual reading, we will use thermal camera to compare the actual reading. For the result, on the first above right picture, we can see the thermal performance of the simulation of core transformer. The highest temperature we will get is 50.38, and the minimum temperature of the winding is 36 degrees. On the right side, we can see the graph of the core transformer that simulate in 100 cycles. And the right below, you can see the thermal camera that used on the site visit. The camera is Flux E76. Oh, sorry, the thermal camera used in the site visit is Flux TI32. And the specification, the for the IR resolution, Flux TI32 and the FLIR E76, both camera use the same IR resolution, but in the resolution, FLIR E76 is better to use than Flux TI32. On the visual camera, we can see the FLIR E76 use 5 megapixel for the visual camera, and the color plates Flux TI32 is more than the FLIR E76. On the level and span, both cameras are a good performance, but for the software, FLIR is more useful because there is more software to use and easy going. For the communication mode, FLIR E76 have a better communication mode that use USB 2.0, Bluetooth, Wi-Fi, and DisplayPort. And for the drop test, you can see FLIR E76 is more durable because it can sustain the drop test for 3 meters. And for the lifespan battery, the Flux TI32 have more lifespan battery than FLIR E76. And for the calibration, it is the most important part. The FLIR E76 have the auto calibration with software, but the Flux TI32 must be calibrated within 2 years. And for the price, Flux TI32 have more cheaper than FLIR E76, but it is more affordable and much recommended for advanced progress. For the communication, as the recommended as in the research, the results for the simulation are quite precise enough to be considered reliable. This is because the parameter of the simulation core transformer has been obtained via earlier study. For the accurate result, the parameter must be get from the manufacturer to make the simulation more realistic compared to the actual outcome. In comparing both thermal camera, it must be compared side by side to identify the difference both for the camera in the spec, to identify which of the camera is the best and more accurate in thermal performance measurement. Thank you. That's all for me. Assalamualaikum.